Lesson 2. Two methodologies that address these challenges today. We have at our disposal two popular ways to meet the challenges we came across in Lesson 1, batch and continuous fermentation tests. While both tests differ in their purpose and application, they both simulate the anaerobic digestion process on a smaller scale. Let's look at how batch and continuous tests work, what they do, and the benefits and drawbacks of each method. Batch tests to study substrate characteristics. Batch tests tell us how much gas can be expected from a material. They also tell us to some extent how fast the material will degrade and the metabolic activity of the microorganism. Batch tests are often called BMP, biochemical methane potential tests, and are the most convenient way to analyze a substrate for biogas production. The test is quite simple. An inoculum is mixed with the sample substrate to test. This inoculum contains all the microorganisms necessary to degrade the substrate. The mixture is then monitored to see how much gas is produced and how much time it takes. Batch tests are best suited to evaluate the substrate characteristics and microorganism activity. For example, it can be used to screen different substrates or to study the effects of different pre-treatments on a substrate, as discussed in Lesson 1. Continuous tests to simulate the process and study long-term effects. Continuous tests simulate a full-scale process by performing experimental tests in a continuous mode. This means that substrate is continuously added to the digester so that you can analyze performance over a long period of time. Gas production is not the only parameter analyzed here. pH, alkalinity, gas composition, VFA, and ammonium contents are also measured. Those parameters give you a better understanding of the process and indicate how various changes may affect its performance. The setup for continuous tests is more complex than for batch tests. It also requires more equipment and human effort. This in turn creates cost and limits the number of tests that can be performed simultaneously. Continuous fermentation tests are most suitable to evaluate and optimize the way a process operates and to study the long-term effects of substrates. To summarize what we've learned, let's look at this table of pros and cons for both tests. Conclusion. While batch and continuous fermentation tests are key to unlocking AD's true capabilities, researchers currently face many challenges in using them. It is very difficult to accurately measure and compare results, and this mainly because of technical limitations. Let's take a closer look at those limitations.